Students, good morning. On the screen in front of you, you see the assignment I would like you to work on this hour. There's a pretty decent chance you'll finish before the class period's over, so please find something to work on. If you finish this assignment either today or tonight, give yourself 2 bonus points. I will not do that for you. You must do it yourself. So give yourself 2 bonus points if you finish the assignment in class or if you finish it tonight, because if you don't finish it in class, you don't have to finish it tonight. It is a Wednesday night. So here's the assignment. Let's see, anything coming up? We'll have a quiz on Friday, and it will be an unbelievable quiz. Please listen to me on Thursday, tomorrow, when I go over what's going to be on the quiz. It will be difficult, it will be challenging, and you're going to have to study to do well. So quiz on Friday. You do not owe me homework unless you never turn Mondays in. If you didn't turn Monday's homework in, then turn that in now at this time, please. So everybody should have turned Monday's homework in by now. And then Tara, you owe me a quiz by Friday. Now, Mr. Harmon's not going to be here Thursday or Friday. He has your quiz, so if you're not going to take the quiz today, Wednesday, get with him and find out where he's going to leave it so that you can take the quiz by Friday. And then all of those incompletes I listed on Monday, I want those done by Friday, okay? By Friday. Okay, this video is a help video, so don't fight over the controls. You're going to rewind, fast forward, etc., and get help on the problems that you don't understand. So please, share the device, work hard. Let's get this thing done in class, or if not, you can work on it also tonight. Alright, let's get started. Numbers 1 through 12, then 14 through 20, then 22 through 26. That's around 24 problems, I believe. Okay, problem number 1. The book says, what is the name for a parallelogram with 4 congruent sides? So, I'm going to sketch this quickly for you. We'll say that length, that length, that length, and that length. All right, and we're going to assume that they all have a slash, a slash, a slash, and a slash. Parallel, 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 parallel. Okay, we have a parallelogram with 4 congruent sides. What do we call that? That is called a rhombus. Any parallelogram that has 4 congruent sides is called a rhombus. Okay? All right, moving on to numbers 2 through 5. They are matching. First of all, number 2 is and of course I'm not trying to be neat, you understand that, is a parallelogram. That's 2 L's right there, parallelogram. And we can write either A, B, C, or D. Well, let's see. All sides are congruent. Yep, that's a parallelogram. Letter B. All angles are congruent. Oh, hold, I better back up. That's wrong, and I apologize. In a parallelogram, all sides are not necessarily congruent. You could have the top and bottom congruent and the left and right, but not all 4. That's not right. Letter B says all angles are congruent. That's not true. All 4 angles are not congruent. The diagonals are congruent. No, maybe, but not necessarily. Opposite angles are congruent. Yes, that is true. So letter D. Okay, let's take a look at number 3. Number 3 is a rectangle. And so again, we have A, B, C, and D. All sides are congruent. No, not necessarily. All of the angles are congruent. Yes, that is true. In a rectangle, you have 4 right angles. Remember, it looks like this. Right angle, right angle, right angle, right angle. So that's true. The diagonals are congruent. Yes, that's true. If you have diagonals drawn in a rectangle, those 2 lines are congruent, and opposite angles are congruent. Well, let's see, is that true? Here's an angle, and here's the opposite angle. Are they congruent? Yes, they are. So B, C, and D are all true for a rectangle. Okay, number 4 is a rhombus. So here we go, A, B, C, and D. All 4 sides are congruent. Let's go ahead and draw a rhombus. There we go. All 4 sides are congruent. That's true. That's true. All the angles are congruent? No, not necessarily. No. Look how big that angle is there. Look how small that angle is down there. So no, that's not necessarily true. The diagonals are congruent? No, not at all. Look how short that diagonal would be. Look how long that diagonal would be. So no, that's not true necessarily. And then opposite angles are congruent. Well, that's true. This angle here is congruent to this angle, and this angle here is congruent to this angle. All right. So yes, that is true. Letter D. And now number 5. Let's take a look at a square. All right. A, B, C, and D. All right. All the sides are congruent. That's true. All angles are congruent. That's true. They're all right angles. The diagonals are congruent. Well, that's true. Definitely, the diagonals are congruent. And opposite angles are congruent in a square? Certainly. Take a look at a square here, guys. There's a square. All 4 sides are congruent. That's true. All 4 angles are congruent. 90, 90, 90, and 90. Look at the diagonals. They're definitely congruent from here to here and here to here, definitely. And then opposite angles are congruent. Well, this is 90 and that's 90. They're congruent. So yes, A, B, C, and D for number 5 are correct. Well, let's continue on to number 6. Number 6. PQRS is a rectangle, so they tell you, they give that to you. This is a rectangle. Never go by what it looks like, but go by what they give you. The length of QS is 12, so I'm going to change to red. Here's Q, here's S. This whole length is 12. Okay, this whole line is 12. Find PR and PT. Okay, remember, in a rectangle, the diagonals are what? Congruent. So if QS is 12, then what does PR have to be? Well, you got it. PR has to be 12. So we answered that part of the question. PR equals 12. PT, well, remember, a rectangle is a what? What's the definition of a rectangle? It is a, that's not right. There's not 2 R's in that. It is a parallelogram. Okay? Parallelogram. And remember, a parallelogram always has diagonals that bisect each other, so this segment here is congruent to this segment here. So PT, cut 12 in half, PT has to equal 6. Okay, so that's PR and that's PT. Moving on to number 7. Number 7, they want you to find the length of AB, the length of BC, and the length of AD. Are they serious? This is pretty funny. What's the definition of a rhombus? It is a, remember the symbol for parallelogram? A rhombus is a parallelogram with 4 congruent sides. So if we have a rhombus, and we do, then all 4 sides are congruent. So if DC is 4, then all the sides are 4. So AB equals 4, BC equals 4, and AD equals 4, because a rhombus has 4 congruent sides. All right, moving on to number 8. We have a rectangle. We have a rectangle, and they want us to find the measure of angle E, the measure of angle F. Wow, are they for real again? The measure of angle G. Wow, this is pretty easy. What's the definition of a rectangle? Do you remember? I'm going to help you. A rectangle is a parallelogram with 4 right angles. So that's a right angle, that's a right angle, that's a right angle, and that's a right angle, because I know I have a rectangle. So the measure of angle E is 90 degrees, the measure of angle F is 90 degrees, and the measure of angle G is 90 degrees. Moving on to number 9. We have a square. If you'll look in your book, well, that's a G. If you'll look in your book, you will see this is a square. They give that to you. Now here's what they want to know. They want to know the measure of angle W. They want to know the length of YZ. And they want to know the length of XY. The length of XY. Okay. Well, first of all, I mean YZ. Look, guys, if it's a square, all the sides are congruent. So if this side's 3, then YZ is 3. And XY also has to be 3. Now, what's the measure of angle W? Well, here's angle W, guys. What's the definition of a square? Do you remember? The definition of a square is a parallelogram with, do you remember, 4 right angles and 4 congruent sides. Ladies, if you don't know these definitions by now, I'm not asking you to go home and read them for pleasure, but you've got to know these definitions, okay? And so the measure of angle W is 90 degrees by definition. Okay, number 10. Number 10 says, use the information in the diagram to name the quadrilateral. Okay, well, let's see. Let's see here. We have a quadrilateral, and we know that we have 90 degrees here, and 90 degrees here, right? And 90 degrees here, correct? Now think about that for a second. 90 plus 90 plus 90 is 270, right? And we know when you have a quadrilateral, all four angles always have to add up to 360. So subtract out 270, we know for sure this angle has to be what? 90. Now, what's the definition of a rectangle? Well, it is a parallelogram with four right angles. Ladies, we have four right angles, okay? So this is a rectangle, okay? If you called it a parallelogram, that would be fine also. It really would, because it's also a parallelogram. All right, let's take a look at number 11. Now, number 11, notice we have a quadrilateral with four congruent sides, okay? Well, look, by the way, we know we have to have a parallelogram. We do, Mr. Earhart? Yeah, remember we learned five ways to state that a quadrilateral is a parallelogram. One of those ways is if this side here is congruent to this side here, and that checks, and if this side here is congruent to this side here, and that checks. So we have a parallelogram with four congruent sides. Now, what would that be? A parallelogram with four congruent sides. Well, that is a rhombus, ladies. That is a rhombus by definition. Okay? And then moving on to number 12, look at this. We have four congruent sides, so we know we have a parallelogram. We know these two are 90. If you have a parallelogram, this angle here has to be supplementary, so we know that's got to be 90. That's got to be 90. Well, we have a square, don't we? We have a parallelogram with four congruent sides and four right angles, so number 12 would be a square. Okay, skipping 13, going on to number 14. Number 14, it says this. Well, you can look in the book. I'm not going to write it, but it says in the book, number 14, it has four, I'll kind of abbreviate it. It has four right angles. So which one of these would it be? Well, we're going to call them number 1, number 2, number 3, and number 4. All right, and you know what? I don't like that idea. We're not going to do that. So here we go. If the object has four right angles, then we know it is either a rectangle or it's a square. Okay, moving on to number 15. That's it. It's that easy. They just want you to name all the possible figures that it could be. Let's take a look at number 15. If you're looking in your book, it says opposite sides are congruent. Well, that would definitely be a parallelogram, right? Parallelogram. A rectangle has opposite sides congruent, so it definitely could be a rectangle. A rhombus has opposite sides congruent, so it could definitely be a rhombus. And a square has opposite sides congruent, so number 15 could be all four. Okay, could be all four. All right, number 16. Diagonals bisect each other. Now, in a parallelogram, do the diagonals bisect each other? Yes. So we know it could be a parallelogram. In a rectangle, do they bisect each other? Yes. So it could be a rectangle. In a rhombus, do the diagonals bisect each other? Yes, they do, because it's a parallelogram, so yes. And in a square, do the diagonals bisect each other? Yes. So number 15 could, or number 16 could be all four. Could be all four. And then number 17, diagonals are perpendicular. Now be careful here. In a parallelogram, the diagonals are not at all necessarily perpendicular. No, not at all. We don't know if that's 90 degrees. And a rectangle is the same thing. I mean, we don't know at all if that's going to be a right angle. Now in a rhombus, we actually have a theorem or a corollary that states, I'm looking for it very quickly. Here it is, Theorem 16. 10 says the diagonals of a rhombus are perpendicular. So whenever you have a rhombus, you're going to have 90 degrees. So this one's a yes. Oops, sorry about that. This one's a yes. Okay. Now, a square. Well, sure, guys. A square is a rhombus. I mean, yes, this is a square, but it's also a rhombus. I mean, it has all four sides congruent, right? And so, yes, anytime you have a rhombus, the diagonals will be perpendicular. So, yes. Number 17, a rhombus and a square have diagonals that are perpendicular. Okay, let's move on to number 18. Number 18 says, find the value of x. We have a rhombus. Find the value of x. Remember, the definition of a rhombus is all of the sides are congruent. Okay? So if all of the sides are congruent, we can take this side right here, which is x plus 2, and we can set that equal to this side here, which is 3x. And now let's go ahead and solve. Let's subtract x from this side, subtract x from this side. Those cancel. 2 equals 3x minus 1x. That would be 2x. And then divide both sides by 2, and 1 equals x. Were you talking to me? Okay. So x equals 1. X equals 1. All right, number 19, we are solving for x, and we have a square. Now, the definition of a square is a parallelogram with 4 congruent sides and 4 right angles. So we know this angle right here is 90 degrees. So we can simply say 5x equals what? Well, 5x has to equal 90. That angle is 90 degrees. So divide by 5, and x equals 18. All right? So x equals 18. Okay, moving on to number 20. Number 20, we have a rectangle. Okay? And I'm trying to see, it's hard to tell what 3x plus 9 is going to. Well, it must be the whole red line. Yeah, I think that's it. Okay, see how this whole diagonal right here in your book is in red, and how this is in red right here? So I'm pretty sure what they're saying is 3x plus 9 is that whole diagonal, and 6x is in blue, and this whole diagonal is in blue. So I think what they're saying is this: the length of this whole red line is 3x plus 9, and the length of this whole blue line is 6x. Now, we know that when we have a rectangle, the diagonals are congruent. We learned that. Okay? I'm trying to look at a certain number. Here it is, Theorem 611. Theorem 611 says the diagonals of a rectangle are congruent. So one diagonal is 6x, the other diagonal is 3x plus 9. So if they're congruent, we can set them equal to each other. All right, let's subtract 3x from both sides. These will cancel over here, and we're left with 3x plus 9. Now we divide both sides by 3, and x equals 3. All right, that's number 20. All right, moving on to 22. 22. Find the value of x in this rhombus. So we are told that this is a rhombus, okay? That is given to us. And we're looking for the value of x, okay? Now let's stop and think about this for a second. Now, students, don't become confused. Don't say, oh, I know. This diagonal here has to be 8, 4 plus 4, so this diagonal here has to be 8. No, no, no. Hold on a second. The only time that diagonals are congruent, let me go back a page, is when you have a rectangle, okay? And we don't have a rectangle. So, these diagonals are not congruent. Now, it is true that they bisect each other, so if this is a 4 here, then I can say PS is a 4. That's true, but that still doesn't help me find x. Okay, let's think this through. Now, what do we know about rhombi? Well, we know that diagonals are, do you remember? Perpendicular. So, that means I have a right angle right here. Now, if I have a right angle, let's pick this triangle up, shall we? Let's pick this triangle up and let's pull it out. let's pull it out. So I'm going to pull it out. Here it is. And this is a length of what right here? 5, right? That's what it says right here. 5. And this length right here is x. We'll call that x. And this length right here is 4. And now I've got a right angle right here, so we'll put a right angle here. Are you not seeing what I'm seeing? I'm seeing a right triangle. Now this goes back to Algebra 2, but I'm thinking, oh, Pythagorean Theorem. Remember? Leg squared plus leg squared equals hypotenuse squared. Or Mrs. Walker might have taught it like this. A squared plus b squared equals c squared. Okay, so here's the right angle. 5 is your hypotenuse, so I'm going to put a 5 right here for the hypotenuse. And then one of my legs is a 4, so I'm going to put a 4 right here for my leg. Then bring down your plus sign, and for this leg I'm going to put an x, so x squared. So here we go. I'm going to kind of run out of room, so I hope this will not thoroughly confuse you guys, but I'm going to pick this equation. Well, I was going to. I'm going to pick this equation up right here. And I'm going to move it right here. Alright, let's continue on. Okay, now I have L squared plus L squared equals 8 squared, X squared plus 4 squared equals 5 squared. So now what do I have? Don't I have x squared plus, let's see, 4 times 4 is 16, 5 times 5 is 25, and now we're going to subtract 16 from both sides, so I'm left with x squared equals 9. And then I taught some of you students this last year. If you have an x squared, take the square root of it, but if you take the square root of one side, you must take the square root of the other side. And the square root of x squared is x, and the square root of 9 is plus minus 3. Now please don't forget, let's go back a page. How in the world could length right here be negative? Well, it can't. So even though we're getting out plus minus 3, we understand the real answer has to be positive 3. So here it is. What does x equal right here? X equals 3. That was a good problem. That would be a fair problem for a quiz, and that's a tough problem. And now for the next 4 problems, 23 through 26, it's going to be extremely difficult. So please pay attention. Please take some really good notes and listen and let me help you, okay? All right, number 23. If you read the directions for numbers 23 through 24, you are told you have a square. Okay, students? A square. Now don't forget, a square is also a what? Rhombus. Okay? So this object here, this figure, is a square and a rhombus, so it has all those character traits. Now, the first thing they want us to find, think about this, students, is, let me take a look and see, HK. HK. Alright? Now, well, also, don't forget what else we have. We also have a rectangle. You say, Mr. Earhart, how do you know all this? Just by definitions. Okay, the definition of a square is a parallelogram with 4 right sides, or 4 right angles and 4 congruent sides. Well, the definition of a rhombus is 4 congruent sides. Well, we know if we have a square, we have 4 congruent sides. And the definition of a rectangle is 4 right angles. And we know we have 4 right angles if we have a square. So it's all of these. So don't forget that when you have a rectangle, the diagonals are congruent. So however long this diagonal is right here, GJ, it's going to be the exact same length as this. So we know from G to L we have square root of 2, and we know from L to J we have square root of 2. Now you might have forgotten how to add these, and that's okay, I'll help you. Square root of 2 plus square root of 2. What's on the outside of this? A 1. What's on the outside of this? A 1. When you have a square root of 2 and a square root of 2 and you add them together, you leave the square root of 2 alone, you do not add it, and you add the outside numbers, the 1 and the 1. So you get 2 square root of 2. So what is the length of GJ? Well, it's 2 2 square root of 2. Now, we have a rectangle and diagonals are congruent. So if GJ is 2 square root of 2, then HK equals 2 square root of 2. So there's number 23. Play it backwards and listen to it again if you need to. But the main thing I want to drill into your head is they told you how to square. As soon as you knew that you had a square, you should have known you also had a rhombus, because all that you need for a rhombus is 4 congruent sides. And as soon as you knew that you had a square, you also knew you had a rectangle, because all that you need for a rectangle is 4 right angles, and we have 4 right angles. Okay, let's take a look at number 24. Now, number 24 says to find the measure of angle KLJ. Well, students, we're done. That's simple. Please follow the red pen. Here's K. Well, that's not what I wanted to do. Hold on. There we go. Here's K, and then we go up to L, and then down to J. Now remember what we have. We have a square, we have a rhombus, and we have a, RH for rhombus, and we have a rectangle. Okay, now a rhombus, we have a theorem that the diagonals of a rhombus are perpendicular. So the diagonals are perpendicular. This is 90 degrees. 90 degrees. So the measure of angle KLJ is simply 90 degrees. 90 degrees. Okay, number 25. Number 25 is the measure of angle HJG. Okay, the measure of angle HJ and G. All right, now let's think about this for a second. Let's first of all, let me put measure of angle equals blank. Now let's trace it. Here's H going down to J and then going up to G. H, J, G. So we're looking for this angle right here. Now students, I want you to use common sense for a second, would you please? Well, I'll tell you what I'm going to do. I'm going to take a blue marker here and I'm going to highlight this triangle. Okay? I'm going to highlight that triangle. And there's the angle that we're trying to get right there. Okay? Let's pull that triangle down here for a second if we could, please. Let's draw that triangle. So there, and then up to there. All right, very good. And now notice this. We know this is a right angle because diagonals are perpendicular, so there's a right angle right there, and we know we're looking for this angle here. All right, let me back that up and do that again. Okay, there, we're looking for this angle here. Now listen to me so carefully, please. I'm going to put a question mark here. Now we know, now don't forget this, guys, we have a rectangle, and that means rectangles have congruent diagonals. That means this line here is congruent to this line. They also bisect each other, so that means this segment here is congruent to this segment here. They have to be. So this segment here is congruent to this segment here. And we know this angle is 90 degrees. Now this goes back to last semester, but you should have learned this. You learned that when you have one triangle, if two sides are congruent, then their opposite angles are congruent. So here's this side, the opposite angle is this one. Here's this side, the opposite angle is this one. Those two angles have to be congruent because these two sides are congruent. Let me go over that again. You should have learned this last semester. When you have one triangle, and within that one triangle two sides are congruent, this side and this side, then their opposite angles are also congruent. So we know that a triangle has to add up to 180, the three angles, and we know this is 90. So we're going to subtract out 90 and we're left with 90. So we know these two angles have to add up to 90. Well, if they have to add up to 90, then that means each one of those angles have to be 45 degrees. So the answer to the measure of angle HJG is 45 degrees. Okay, and we're finally done, so cheering is allowed, that's fine. Perimeter of triangle HJK. Alright? Triangle H, not angle, but triangle HJK, and then back up to H again. So students, we want the perimeter, okay? Well, like I love to do, let's pull this triangle out. I think that's very wise to do. So there it is. And first of all, can we please very quickly go back to number 23? Remember how we found the whole length? Do you remember that? We found the whole length of HK right here. That was back on number 23. And what was the whole length of HK? Right here. Right here it is. 2 square root of 2. So now let's zip ahead. We already found the length of HK. It's 2 square root of 2. Now, how long is this side here? 2. And we have a square, so how long is this side here? 2. So we put a 2 here. And then, of course, this has to be a 2, right? So if we're going to find the perimeter of this triangle, then we have 2 plus 2 plus 2 square root of 2. Now, in Algebra 2 last year, Kate and Ashley, your class, and Megan, your class, Bridge Math, we did learn how to add and subtract radicals or square roots. And what you learned is if a number like this does not have a square root with it, then you cannot combine it. It's almost like they're unlike terms. So I can definitely put these two numbers together. 2 plus 2 is 4. But I cannot combine that with 2 square root of 2. Okay? So that is your final answer. Look up here. It would be like having x plus y. X plus x would be like terms, so you would put 2x, but you could not add the y, so you would just bring the y down, and that would be your answer. Okay? Well, it's the exact same thing over here. These two terms are like terms, so put them together and you get a 4. This has a radical, so just bring it down, and that's your final answer. I hope this has been a help to you. Please study, please work hard, have your homework done. This homework is due tomorrow. Now, if you don't finish it in class and you don't want to finish it tonight, that's fine. It's a Wednesday night, but if you'll finish it either in class or tomorrow, before class starts tomorrow, then give yourself the 2 bonus points. Okay? Have a nice day.